receptors are, mainly they are proteins. ठीक है ना? If we talk about only receptors, so receptors are basically proteins only, they are nothing else. So if we talk about the action of the receptor, so for that first you have to know about the receptor. Now see, there is a, let's take an example. Imagine this is your house. ठीक है ना? This is your house, and this is the room of your parents, like the boss of your family. Now imagine that there is a situation that there is a person who are invited. Now see, sometimes imagine in your house there is a house party going on. Okay, so in your house party you will see normally क्या होता है ना, there are two types of people who are invited, two types of relatives who are invited. So relative number one, you will see that they stay near to your house, एकदम like नज़दीक वाले, एकदम like few, not even 1 kilometer or maybe within 2 kilometers of distance. Like even if you sneeze in your house, then also they get to know कि हाँ, this person has sneezed 3 times today. Like all informations are exchanged over there day to day. And
আগে এটা বলেছিলেন যে যেটার মানে কি বলবো, যেটা অয়েল সলিউবল সেটার কোনো ইয়ে লাগবে না, মানে কোনো কাউকে জিজ্ঞাসা করতে হবে না, and যেটা is not soluble it has to take some permissions, that means it has to cross the other receptor or something like.
Yes, so if I talk about A category molecule, so A category molecule will require some receptor at the doorway, because they are like the distant relatives. Even if the door is open, they will still ring the bell. You have to go to the door and you have to receive them ki haan, please come in. So that is A category. So for A category, what can it be? Like these relatives, they cannot blend in with your family suddenly. So like the membrane is non-polar, so they cannot blend in. That means who cannot blend with non-polar? Definitely polar. So if the substance is polar, then definitely you have to receive that substance from the surface only. Another situation is that if this molecule is very very big, like imagine if we talk about Dr. Devoshmita. So in her house all the doors are made according to her height, so that only she can go in and go out, and people like her can go in and go out. Now imagine that if one relative comes up who is like Khali, the great Khali, do you think that person can enter in through that same door?
No, sir.
Right. So that means its size is also very important. So that is, it is not, I didn't write M and ulta M, it is MW, molecular weight. So anything which is having a very very high molecular weight, or if you see that there is anything which is polar. What can be polar? Have you heard of something called as catecholamine? Catechol group with amine. Like you will get it in say adrenaline. Okay, so epinephrine. All right. So these are all catecholamines. They all are grouped under catecholamines. And if we talk about high molecular weight, so if it is high molecular weight, you will notice that they mainly belong to your say insulin can be a good example. Even easy way to remember, all your anterior pituitary hormones. Anterior pituitary, what do they give? FSH, LH, prolactin, growth hormone. Okay, they all have high molecular weight. So all these things, they cannot enter in just like that. You need to go to the door, you need to go to your premises, you need to go to your gate to receive them. But if we talk about another molecule, that is B category molecule, these are the relatives who stay nearby. They don't need anybody's permission, they will directly enter in. So if they directly enter in, so you don't need to go out, you can simply stay in. You can stay in and you can watch TV, and you will see automatically they are entering in, and they are saying that, hey, get me a glass of water, get up, get me. They do that. They start showing their dominance suddenly. Okay, so they will be directly entering. So who are these people? So they can be definitely low molecular weight, chotu people. you didn't notice that they entered, they are so chotu, suddenly you find that they entered. So chotu people, the low molecular weight people, and the other one is going to be non-polar, who can easily pass through your doorway. Your security guard at your home is not going to catch them, so they can blend in. So non-polar blends with non-polar cell membrane. So non-polar substances mane anything which is steroid, sterol, okay, like testosterone, progesterone, okay, these are all steroidal, aldosterone. So all these molecules, they are all non-polar, they can actually diffuse in directly. If I talk about low molecular weight substances, a very good example will be the thyroid hormones T3 and T4. So these are the molecules which you will see, they are all grouped under this like a separate category, where you do not need to put the receptor on the cell surface. That means, what do we learn? We have a receptor that is intracellular receptor or intracytoplasmic receptor, and we have got another receptor, and that receptor is what? Cell surface receptor. So this is going to be a cell surface receptor. So if we talk about the cell, first we will talk about cell surface receptor, ठीक है ना? So if we talk about cell surface receptor, there can be various types of cell surface receptors. A few things we have already discussed earlier, and it is there on the screen also, that there are major receptor families. Do you see on the right hand side? 4 families: ligand gated ion channel, G protein coupled receptors, then enzyme linked receptors, intracellular receptors. On the right hand side, major receptor families. Yes. So we'll just have a basic understanding of what are these cell surface receptors. These are all categorized under cell surface receptors. So suppose I hope everybody is understanding, or is it visible, I guess?
Yes, sir.
Yeah. So this is basically lipid. I'm not going into details, I'm just making a schematic. So this is a cell membrane. So situation number 1 can be like last class I think I gave you an example that suppose there is a transmembrane protein. Do you understand that this is sort of protein, transmembrane protein, and it is, what is the 3-dimensional shape of this? Are you understanding?
Sir, অনেকগুলো প্রোটিন কাপল করে দেখা
হ্যাঁ, but what is the shape? Every shape has a name, na? Like 3D shape, sphere, cuboidal, cube. So what shape is this?
কিউবয়েডালের দিকে বলতে পারবো। It's not good shape as.
Last class I told you that suppose there is a protein which is like this, then there is another protein which is like that.
হ্যাঁ, ওগুলো স্যার জয়েন্ট করবে।
হ্যাঁ, তো shape,
Cylindrical.
in the lower diagram, isn't it looking cylindrical at all? My
Oh,
artwork is poor, but
It's
cylindrical, na? So remember, in this cylindrical structure, sometimes you will find that there is present a notch. There is present a notch over here. What for? Now inside this notch, suppose there is a receptor which comes up and binds over here. Suppose a ligand comes up and binds over here. Immediately things will start to enter in. This will open up. Are you understanding this?
Yes.
So this is the ligand, and this is going to be the first type, that is ligand gated ion channels. Of course, what is going in? Of course, ions are going in. So these are examples of ligand gated ion channel. Now imagine suppose there is this one protein, and let us suppose that this is a protein chain of protein, and then this goes like this, then it goes like that, then it again goes like this, goes like that, then again it does like this, again that. Now since time and space is very important for me, so I'm just making it schematic. So do you realize that in this way it is possible?
Yes, sir.
Yes, this is a protein. Now in this way I'm just making a rough picture of this, or okay, why rough picture, let me. So this protein can also be present as a transmembrane protein, like over here. Okay, this can be present as a transmembrane protein. Understanding? Okay. So if this protein is acting as a transmembrane protein, so this is also such a kind of thing that is called as a G protein coupled receptor. Now why is this called G protein coupled receptor? I'll tell you. So here what happens, here there is present a very special protein, and I'll draw that protein here for you. So there is this protein, and this protein has got 3 subunits. It's a trimeric protein. So suppose this is alpha subunit, this is beta subunit, and this is gamma subunit. Now the speciality is that this protein is always in contact with another molecule, and that is called as guanosine let's say guanosine diphosphate, GDP. So what happens is that wherever this protein will be present, wherever the receptor will be present, okay, wherever do you realize this receptor, wherever this receptor will be present, in that area this protein will always be present. So this protein, do you realize that this protein, the trimeric protein, it is always associated with guanosine? Yes or no?
Yes, sir.
So that is why this is called as a G protein. This is called as G protein. Later on we will detail on all of these one by one, but for the timing just I'm introducing you to the receptors. So that is why it is G protein, because it is associated with guanosine. Now another thing, the receptor that is always coupled with this G protein, that is why it is called as G protein coupled receptor. In short, how do we write it? We write it as GPCR. It has got many names, okay, like look at this, it looks like a snake, so since it is having a shape of a serpent, so many authors call it as a serpentine receptor. And since this receptor is, it is winding the membrane. So if this is a membrane, so it is winding the membrane. So 1, 2, 3, 4, 5, 6, 7. So it is winding the membrane 7 times. That is why it is called as a 7-pass receptor. It is passing through the membrane 7 times. So this receptor has got many names. It can be a GPCR, a G protein coupled receptor, or it can be a serpentine receptor, or it can be a this 7-pass receptor. Now moving on, then we can have another receptor, and in this receptor, this is like very simple type. So what happens is, sometimes you have certain receptor which are like this. There is this receptor. Now the ones that I will be teaching you, they are mainly dimeric. So that is the diagram I am drawing over here. Now what happens is, suppose a ligand comes up and binds over here. Now if a ligand comes up and binds over here, you realize that both these subunits will be pulled towards each other and they will form a single unit. We will learn all these things in detail, but for the time being, do you realize that these are the two things? And when suppose a ball comes up, your hands are like this. Suppose a ball is trying to drop, will you keep it like that, or will you try to do it like this? You'll try to do it like this, right? Now when it happens, like ligand, of course ligand. of course, affinity. So for the purpose of affinity, they will all come up towards the ligand. This one is attaching to the ligand because of its affinity. This one is attaching to the ligand because of its affinity. Understood? Now, the trick here is कि these proteins, they are associated with a very, very special kind of enzyme I will teach you, that is called as tyrosine kinase. So tyrosine kinase. So you see, it's a ASE, tyrosine. Anything which ends with ASE. What is that? It is an enzyme. So tyrosine kinase is an enzyme, and this receptor is linked to the enzyme. So that's the third family of receptor, that is enzyme linked receptor. Understood? So what is enzyme linked receptor? Now, once you have discussed about this enzyme linked receptor, then comes up the intracellular receptor. So intracellular receptor we will discuss separately. Right now I am not focusing on that part. So now we have to, if you have understood this, then we will go on detailed discussion on the this cell surface receptor. So first you tell me that have you understood this part or not?
Yes, sir.
Acha. All right. So in short, here only I would like to add, because there is nothing more in this story, that is one example of this ion channel, like the first type, that is ligand gated ion channel. One good example for that is the GABA receptor. Okay, so there is this receptor of, I'll write over here. You know GABA, there is a molecule called as gamma aminobutyrate or gamma কি?
ওটা তো ইনহিবিটরি রিসেপ্টর না?
হ্যাঁ, why? Because the ion which is entering, that is a chloride ion. So chloride ion মানে there is gain of anion. Gain of anion মানে, if this is minus 70 millivolt, gain of anion মানে cellular environment is becoming more negative.
ইলেকট্রোপজিটিভিটি আর হবে না।
হ্যাঁ, তো more negative মানে it is getting hyperpolarized. So it will be very difficult to reach the action potential. So that is why GABA is inhibitory. So this is the reason. So remember this stimulation of nicotinic receptor by acetylcholine. You remember nicotinic receptor? I will teach you, but in physiology last year you have studied stimulation of nicotinic receptor. It's a cholinergic receptor. So acetylcholine can trigger it. So stimulation of this nicotinic receptor by acetylcholine, that results in sodium influx, and that causes action potential. So that's an excitatory thing. But if we talk about, say, later on I will teach you, there is a category of drug called as benzodiazepine, diazepam, Valium. These are all types of what? Sedatives. And how do they sedate you? How do they calm you down? They make you calm down. They make you MS Dhoni. Why? How? Why? Na? Sorry. How? How do they make you like the epitome of Mr. Calmness? Because they open up chloride ion channel. So when it binds to the chloride ion channel, there is chloride influx. Cell goes hyperpolarized, inhibited. So some examples. You understood? Examples: nicotinic stimulation of the nicotinic receptor by acetylcholine. That's number one. Another example I have given you, that is the GABAergic receptor by GABA. Okay, right. So now let us talk about this transmembrane G protein coupled receptor. Now, if we talk about this transmembrane G protein coupled receptor, so remember this ki G protein coupled receptor. Now here what happens? What is its behavior like, or how does the game goes on? Because here we have to know a few basic things. G proteins again are of various types. Understood? How they are of various types, I'll just give you an idea. So once again I'll draw that picture. So I'll first give you the basic idea of a G protein coupled receptor, how it works. So okay, this is my cell membrane, and I'm not decorating. So this is going to be I'm drawing a simple picture. 1, 2, 3, 4, 5, 6, and 7. So if you notice, in this receptor, this is the area where the ligand will bind. I am changing the color and we can see this is the area where the ligand will bind. Now what will happen if the ligand binds? So suppose the ligand binds, suppose this is the ligand, and this ligand binds to this receptor. So you will notice that 2, 3, 4, 5, 6, 7. You will notice that once ligand binds, the intracytoplasmic domain, that changes its configuration. If its configuration was like this, now the configuration becomes like that. Could you notice this? I am changing the color again. This part I am talking about. So this is the effector domain of this receptor. So the receptor has got, like we can see, there is a ligand binding domain, there is a effector domain, and in between there is a transmembrane domain. Okay. So now what is the result of this change? The result of this change is initially what have we learned? Initially we have learned suppose there is the G protein. So let me draw a G protein for you. Oops. Okay, let this be the G protein. So what have we learned? There is this alpha subunit. How many subunits will be there?
Alpha, beta, gamma.
Alpha, beta, gamma. And they all have a bonding between all of them. So they are all very well connected friends. Now as soon as configuration changes, and also, okay, we should not forget that thing that I mentioned, that here there was present guanosine diphosphate. Now as soon as configuration changes, what is the result of this configuration? The result of this configuration is now GTP, it enters and it kicks out GDP, says Garibi Bhagao, and kicks off this GDP, and GTP enters in. Understood? Now if GTP kicks out GDP, now alpha subunit has got very high energy. So now if alpha subunit, see phosphate one energy, I hope you know these basics. Phosphate bond, high energy bond, ATP, ADP, GTP, GDP, UDP, all high energy. So now alpha is very, very energetic. So if alpha is very, very energetic, do you think alpha should stay like that, quiet and calm, or alpha should move? What do you think? Alpha should be staying like move korbe. So alpha subunit, it is expected that alpha subunit should keep moving. Alpha subunit should move. So if alpha subunit starts moving, do you think it can remain attached with this beta and the gamma? No, never. So what happens here is that beta subunit and gamma subunit, they just detach out. So this is the main difference that takes place when ligand binds. Understood? So when ligand was not there, situation is on left hand side. When ligand got attached over there, the situation is the second situation. Clear, everyone? Now over here, what happens if this alpha subunit becomes very, very energetic? Now here there is present another transmembrane protein. So there is this one transmembrane protein present over here. It's quite, imagine you have got suddenly too much amount of money. So you will see whenever you get high amount of money, immediately the bank officials, then credit card wala, then anybody who wants money, these scammers, okay, these fraudsters, they immediately start chasing you. You will never see scammers are chasing school students and all who don't have money. They always chase the people who earn. So whenever you have money, then like nowadays stock market, these mutual funds, they say that invest the money in us we will give you good return. Do you know these type of things go on in the world? Do you have such commercial idea?
That's it.
Yeah. So there is this businessman, and this person says that okay, alpha subunit, you have got too much energy, I want to utilize your energy. So you come up with your GTP, you come up with your so much huge energy. So alpha subunit says okay, fine, but for what? Says that if you come up, then my company will be investing your energy and will be creating products. So alpha subunit says okay, so what product are you going to create? So this person says that oh, I am going to buy some raw material from the market called as ATP, and I will convert those ATP into cyclic AMP. So as long as you are associated with my company, I will keep producing cyclic AMP more and more and more and more. Okay, so what is the name of this businessman? The name of this businessman is adenylyl cyclase. Adenylyl cyclase. So adenylyl cyclase will be converting ATP into cyclic AMP. Clear, everyone? Okay. So what is the point of having so much amount of this cyclic AMP? What if what will happen if I don't get this cyclic AMP? So let's understand that what does this cyclic AMP do? Now cyclic AMP binds with another protein. Okay, so here we will come across another protein. Okay, so there is going to be another protein present over here. Now the job of this protein is to phosphorylate. The job is to phosphorylate. What do you mean by the word phosphorylation or phosphorylate in simple layman language, Asan Bhasha?
Phosphate.
Correct. And who can tell me the name of an enzyme which always adds phosphate? From the name only you can understand that it adds phosphate. So what is the name? What is that name? Anyone knows?
Phosphatase.
Phosphatase means addition of phosphate. Really?
Phosphate to দিচ্ছে attack করছে স্যার।
আচ্ছা, everybody agrees कि phosphatase মানে addition of phosphate?
না, sorry. Phosphatase মানে তো removal হয়ে যাচ্ছে।
Phosphatase মানে breaking down phosphate. So any other idea that what is the name, common name? It's very commonly used, the name, and commonly used for various places, wherever and whenever you come across this name, you know one meaning, that is here there is addition of phosphate going on. So one word that is always used, I think I should tell it, you don't know, na? Acha. So the word is kinase. Kinase mane it will always do phosphorylation, it will always add phosphate group, remember this. So this is a protein, of course chemical nature, enzyme mane it's after all a protein. So it's a protein, and let me write protein which has got phosphorylating activity. And when is this activity coming up? This activity is coming up when there is cyclic AMP. That means this protein is activating under the influence of adenosine, correct? Hence we say that this is called as protein kinase A. Okay, this is called as protein kinase A. So you understand the justification of the name protein kinase A. So let's see what it can phosphorylate. So normally what happens is it can activate some enzyme, it can activate some sleeping enzyme, inactive enzyme, it can activate some inactive enzyme. So if you add phosphate, you are adding energy to a sleeping enzyme. So do you think that enzyme will be dormant and sleeping anymore, or it will get activated?
অ্যাক্টিভেটেড হয়ে যাচ্ছে।
Yes. So you can phosphorylate some cytosolic enzymes. Okay, for example, phosphorylase kinase. There is enzyme phosphorylase kinase, so that can get activated. ठीक है ना? So you can activate some, this inactive enzyme and bring about biochemical alteration in the cell. Or you can also phosphorylate some inactive transcription factor. You know transcription factors, genetics?
হ্যাঁ স্যার।
And you can bring about genetic alteration in the cell. You can bring some altered expression in the cell. Or you can also phosphorylate, when you can add actually phosphate. Let me do it like this a little bit, just a sec. Suppose this is your, I'm just drawing the boundaries of the membrane, cell membrane. I hope you're getting. This is the cell membrane I am trying to make. So now what I am saying is that it can also happen that if this is the cell membrane, then in this membrane there is present, once again, who can understand this Wahyad artwork? Who remembers this protein? Ion channel, yes. So you understand ki if suppose some phosphate actually comes up and binds over here, then don't you think even this ion channel can open up? And if this ion channel opens up, then there is going to be electrical alteration in the cell or electrochemical alteration in the cell. So do you realize ki what is happening over here, ki if a ligand binds, then what all changes can come up over here? Like suppose if the enzyme gets activated now, so there is going to be another thing that is called as a cyclic AMP response element binding protein. So there is this another protein, there is this another protein that is called as cyclic AMP response element binding protein. So it is called as CREB in short. And if CREB gets triggered, then again that is going to act on what? That is going to act on the, any idea? That is going to act on what? Yes, you understood. Not understood. It will act on your genome. Okay, if it gets activated, it will, this is a transcription factor also. CREB is also a transcription factor. It can also again trigger transcription. Even a transcription factor separately, if it is inactive, then that can also activate, and that can separately again do some other transcription. Different cells have their different stories. Okay, like if I take an example, let's talk about one story. So let us suppose this entire yellow colored cell that I have made, this is a cardiomyocyte, heart muscle. And let's suppose ki this beautiful stuff present over here, this is epinephrine. So when epinephrine binds, then what happens is this G protein gets activated, alpha subunit goes and binds to adenylyl cyclase, cyclic AMP starts increasing. Now what happens is here, when protein kinase A will get activated in the heart muscle, it will open up sodium ion channels. So if sodium ion channel opens up, then what happens? Sodium goes inside the cell or out of the cell?
Ion channel open হলে তো সোডিয়ামটা বাই পুরো ইনফ্লাক্স হচ্ছে।
Sodium influx হচ্ছে, so there will be sodium influx. So there will be gain of cation. Cation will be gained by the cell. If it was minus 70 millivolt, then now actually in heart muscle it will be minus 90, but whatever it is. So but my point is this: gradually there will be depolarization developing because potential is increasing, so there will be depolarization towards the action potential, and you will see, now you understand why sodium causes increased heart rate, and how epinephrine can cause an increased heart rate, how adrenaline causes an increased heart rate. Do you understand that? So different cell will have different stories. Like if you observe one thing, ki if cyclic AMP remains attached all throughout the day, then always there will be phosphorylation going on all the time. So suppose, let's say somebody calls Dr. Obhirup from right side. So when the voice goes inside the head of Dr. Obhirup, so what happens is he turns his head towards that direction where the sound was coming from. Correct? Now, cyclic AMP got stimulated in his muscle, suppose. That is how the stimulus came up. So will Dr. Obhirup keep his head turned like that only? Like suppose somebody calls me from left hand side, I turn like this and I remain like that, because here there is the cyclic AMP na? So my muscle got activated. So will I remain like this forever? Does it happen that way? No. I'll come to that part in a while, but okay, one more thing to observe here. That is, see, as long as cyclic AMP is high, if there is suppose one cyclic AMP high, that means there will be constant phosphorylation going on. This much is agreed. So imagine if there is one epinephrine binding to a receptor, do you realize that, do you believe that there will be one G protein getting activated, or like say 10, 20, 30, 40 G proteins getting activated? What do you think?
Sir,
Multiple hobe. So if say 100 G protein or 10 G protein getting activated, do you think 10 G protein can activate only like one protein kinase, or it can activate like 100 protein kinase? Correct. So if there are 10 G proteins, they will activate say 100 adenylyl cyclase. So if one adenylyl cyclase, do you think one adenylyl cyclase will produce one cyclic AMP? No, na? It will produce again say hundreds of cyclic AMP. So if there are 100 adenylyl cyclase, you understand there will be 1000, 10,000 cyclic AMP getting formed. Correct? If there are 10,000 cyclic AMP getting formed, then there will be even more number of protein kinase A getting activated. So in each step, what are we seeing? That there is a gradual exaggeration of response going on. At every step, we are seeing that there is a gradual exaggeration of the steps going on, or exaggeration of response is going on. This is called as biological amplification. Okay, this is called as biological. Okay, I'm not writing here. Okay, this is called as biological amplification. Understood? Amplification. There is amplification going on in biological structure. Also, normally amplification is the thing that we see in sound, so that's like a physics thing. But in biology also we see, in our body also there is amplification going on. Amplification of response is going on. So that is what is called as the biological amplification. Clear? Now, over here, if you have understood this part, now let me tell you that since we are talking about cardiomyocyte, then the story is not so simple. The story has got like even more stuff over here. So what happens is ki this adenylyl cyclase, it has got one more portion. So let me draw it in this manner. So it has one more portion like this. Now there will be another kind of receptor. Now since I have already shown you how it works, so I am not decorating it again and again, and I am just saying that once the ligand binds, here also configuration changes in what, which domain? There will be configuration change in the effector domain. है कि नहीं?
हाँ सर, टेलटाते.
हाँ, टेलटाते. And you will see that here there will be another G protein which is getting activated. So beta and the gamma getting separated. Okay, beta, gamma getting separated, and alpha subunit with GTP gets attached over here. क्या बोलते हो?
Yes, sir.
Now what happens is, when this happens, what you will notice कि this is actually giving a negative feedback to adenylyl cyclase. So what happens? Cyclic AMP level, will it keep going higher? Will cyclic AMP level keep going higher?
না
Na.
তাহলে তো নেগেট করলে তো হবে না।
So gradually and slowly inside the cell, cyclic AMP level starts to decrease. And if cyclic AMP level starts to decrease, then protein kinase A will again get inhibited. What is the name of this molecule? What is the name of this ligand? This is none other than the very beautiful, the very dashing acetylcholine. So you understand कि suppose if we consider that one day Dr. Shomili went out of her house and saw somebody crossed her. Somebody, समझ रहे हो? Tom was cruising in front of her. So what happened is, Shomili's heart rate went high. Why her heart rate went high? Now you understand why. Because there was a lot of epinephrine released, and because of so many epinephrine, her heart rate went high. Then there was a situation. We realized that Shomili is developing palpitation, heart rate is not coming down. Now she is feeling sick. Now she is brought to the hospital. So what will the others do? What will rest of you, the doctors, you will do? So you have to understand that epinephrine has been increasing the cyclic AMP level in her cardiac muscles. So to save her, you have to inject acetylcholine. So this is how the treatment goes on. So today's discussion is actually very, very interesting, because this is a very pillar. If you understand today's discussion, then it will be helpful in not only your second year pharmacology and understanding of the drugs, but it will also help you the physiology, understanding of the hormones. It will also help you in understanding medicine, how medicines work, how diseases occur in your body. I'll tell you how, I'll tell you gradually. So see, it is, so do you realize that the first time the G protein that we talked about, that G protein, the left hand side wala G protein, that is having a stimulating nature. Correct ki na? It is having a stimulating nature. We call this one as the G stimulatory, GS protein. Understood? And over here we will, like in the same way, this G protein, this is not having a stimulatory nature. So this is having an inhibitory nature. So we can say it is a GI protein. So it's a G protein inhibitory, GI. That's a G protein stimulatory, so GS. So remember, there will be three types of G protein: GS, GI, and I will teach you in a while. There is another one, that is GQ. Okay, but anyway, so do you understand this stuff? What is going on over here?
Yes, sir.
Now another thing. So another problem. So this is, so we understand that there are various types of G protein. That is one thing. Next thing is that I told you that there is a query. What is the query? That how long will this action survive? How long will this action sustain? So the answer is few seconds. So what will happen within few seconds? Two things. Number one, there is an enzyme called as phosphodiesterase. So from the meaning phosphodiesterase, in simple language, tell me, it is adding phosphate or removing phosphate?
Phosphodiesterone ভাঙে, so
Remove phosphate. So what happens is, slowly and gradually, this phosphodiesterase, PDE, I'm writing in short, phosphodiesterase will convert it into 5' adenosine monophosphate, 5' AMP. So cyclic AMP is, do you think there is any more cyclic AMP present after few minutes? No, in absence of stimulus. If you keep giving stimulus, then that's a different story. But in absence of stimulus, within few seconds or few minutes, the cyclic AMP level will automatically start to degrade, because some small amount of cyclic AMP will get converted into AMP, adenosine monophosphate. This is thing number one. Thing number two is alpha subunit. It has its own intrinsic GT-phase activity. Okay, it has got its own intrinsic GT-phase activity. So if there is GT-phase activity, then you understand inorganic phosphate is going out. So from GTP, if you remove an inorganic phosphate, तो बचा क्या? What is left?
GDP.
Correct. GDP माने now again alpha subunit has got low energy. Do you think our businessman adenylyl cyclase will give him job? Nah. So definitely again it will require its friends, and when it will get so many friends, again it will be back to its original condition. Understand how the thing is going back to its original situation in this way.
It's a full cycle.
So this is the entire game that is going on. Okay, like I'll give you an idea that how important is this thing. So you see, if there is a bacterial toxin. Okay, now there is a bacterial toxin. Have you heard of the thing called as Vibrio cholerae?
Yes, sir.
Comma-shaped bacteria, Vibrio cholerae. It releases a toxin called as the cholera toxin. ठीक है ना? Now, when cholera toxin binds to the receptor present on the cell, then the toxin is internalized. Okay, the cell absorbs the toxin. Now, when cell absorbs the toxin, it is basically a ADP ribosyl transferase that transfers the ADP ribose from NAD to an acceptor site on alpha subunit of the G stimulatory protein. So what happens now? This is a covalent bond. So what do you think? Covalent bond is a strong bond or a weak bond?
Strong bond.
Strong bond. So when this NAD, from the NAD there is ADP ribose going and binding to the alpha subunit of the GS protein, its intrinsic GT-phase activity which was there, that is gone. In short, in simple language, cholera toxin enters and damages the GT-phase site of your alpha subunit of GS, माने alpha S. So alpha stimulatory subunit का what do you say, GT-phase site is destroyed by cholera toxin. So do you think, so what do you think here? Action will be, think carefully and tell me. So action will be prolonged or there will be short action? Think carefully, everyone. GT-phase site of alpha S is getting destroyed by cholera toxin. So stimulatory action, tell.
It's a prolonged action হচ্ছে কারণ GDP থাকছে, তো GDP-টা তখন ইউজ হবে ইনসাইক্লিকেন মানে কি এটা।
আচ্ছা, and what about the rest of the people? What do you think?
Sir, prolonging movement.
Okay, right. So there will be prolonged condition. Now where this happens, you know, this happens in your intestinal cells. Now since it happens in your intestinal cells, what happens? There is always a sodium channel opening. Sodium is going out of the cells and going where? In the lumen of your gut. And where sodium goes, who travels? Who goes along with sodium all the time? Wherever sodium is going, who else goes? Tell.
Potassium.
No, water goes. Why will potassium go? Wherever sodium goes, there water will be going. So the lumen of your gut is loaded with salt and water. So if some patient's gut is loaded, packed with salt and water, what do you think the patient will experience?
Accumulation of fluid or
in the gut lumen, inside the intestine, lumen of the intestine, there is accumulation of salt and water. So patient will tell fluid retention.
হ্যাঁ মানে ফ্লুইডটা তো ইনটেক হচ্ছে।
Rest of the people, do you agree? Inside your intestine is tight, loaded with salt and water. What will you experience, or what will the patient experience?
স্যার ডিহাইড্রেশনও তো হতে পারে।
Dehydration, yes, of course. Hote pare, I mean, that is dehydration. How will, like, somebody's lumen is filled with salt and water, patient will feel fluid retention? What sort of a feeling is that? Like some
স্যার মনে হলো মানে জল জমছে মানে সেটাই।
কারণ পেটে যদি প্রচুর জল থাকে তার এই ফিলিং আছে যে জল জমছে, like if you drink too much amount of water, somebody asks you, okay, why are you having discomfort, you will say, I think there is fluid retention.
না স্যার
You develop like diarrhea, you develop loose motion, and that is the main problem of cholera. Now understood?
হ্যাঁ স্যার
So you see, this is the thing, and not only about this. This thing is happening with cholera. There are two bacterial toxins which do this kind of stuff, and another one is the pertussis. Have you heard of pertussis? Bordetella pertussis is an organism. Pertussis is also ADP ribosyl transferase. Same stuff, but this time this is happening in your bronchial tree, bronchial cells. So here what will happen? There will be lot of secretion. The cell is active, cell will be remaining active, same story. In your bronchi, if cell remains active, definitely salt water is not coming out from your bronchi, mucus will come out. More mucus will come out, your body will try to get rid of it, and do you know Bordetella pertussis or don't know? Bordetella pertussis is basically the causative organism for whooping cough. So why does the patient cough again and again? They keep coughing because of this reason. That, you know, since the bronchial cells, they release so much amount, they are always active. Their activity never goes down. They are always active. They are so active that it keeps producing mucus. So since there is a continuous production of mucus, you keep coughing, and you develop whooping cough. Understood?
হ্যাঁ স্যার
Okay. Then you can also remember, like, there are so many things. Like there is a disease called as the McCune-Albright syndrome. Have you heard of this? No. So
না স্যার এটা শুনুন
okay, so it's a very common disease. You will study not only in here, but you will also study in your oral path as well. I think next year. So in McCune-Albright syndrome, there is mutation in the neural crest cell. In embryology, I've studied neural crest cell.
স্যার তাহলে তো সেটা এমব্রায়োনিক স্টেজে হচ্ছে।
হ্যাঁ, of course embryonic stage হচ্ছে. So during this embryogenesis only, in the neural crest cell there is some mutation. So what happens is, all the descendants of these cells, that is, like, what are the descendants? Some of the neural crest cells convert into osteoblast, some of the neural crest cells convert into your melanocytes, some of the neural crest cells, they are forming testicular cells, some of the neural crest cells forming ovarian cells. So all these descendants of these neural crest cells, NCC, they express the mutant protein. Understood? They produce the mutant protein, and this protein leads to, you know, a condition called as osteotic fibrous dysplasia, and you will also see that there is a abnormal pigmentation in your skin, which in oral pathology you will read. It comes as a question: cafe-olate spot. Cafe-olate. It's like the coffee colored spots. So it's a cafe-olate spots, and there will be puberty, precocious puberty. Okay, so cells remain so much active because of this mutation. So there are too much pigmentation. Okay, there is like excessive, some places where there will be excessive bone formation. Okay, too much bone. So fibrous dysplasia will take place. Too many fibers, too much collagen will be formed, pigmentation will be formed a lot. Okay, and gonadotropin independent. This is not due to gonadotropin, it's just because of the mutant protein. There will be precocious puberty. Do you understand precocious puberty?
স্যার ওই আগে পিউরোমাটি হয় আর একটু রিটার্ডেড হয়।
Correct, right. So all these things happen. So there was this Dr. Fuller Albright. So he documented this type of thing, and accordingly we got the name. Gradually story came up. So anyways, that's a different situation. But my point was to explain to you how important today's discussion is. So if you really understand today's discussion, then definitely it will be helpful not only in understanding the drug action, it will helpful in understanding hormone action, it will be helpful in understanding the disease. So basically you can understand it's almost a pillar of medical science. So this type of discussion you should thoroughly understand. Okay, done everyone?
Yes, sir.
Right. Now moving on. So I'm going to tell you another story. Like I told you, different cells have different stories. So let me talk about one more kind of a different story. So once again, let me draw a cell for you. Okay, so once again I'm going to draw this particular cell for you. This time let's make a better looking cell with good cosmetic and aesthetic value. So I'm trying to make a very beautiful glamorous cell. Is this cell looking glamorous? I don't know, at least it has some curves. I made it curved. Lol. So anyways, so over here once again I'm going to make that kind of a that receptor. So I'm not going into the details of it because you already know it. So it's a G protein coupled receptor, hai ki nahi?
Yes, sir.
Correct. And if it will remain the effector domain remains like this, but if ligand binds over here, then effector domain will change its configuration. This also you know. So suppose there is a ligand binding over here. Let's say the ligand is our same ligand, epinephrine. It's like since you have already understood, this time let's take a solid example. Let's suppose this is you have studied about adrenaline. Adrenaline has got many receptors. So did I teach you that there are some sub families like nicotinic, muscarinic last class? Then alpha, beta receptor. So now let us consider that this is a beta adrenergic receptor. There is a beta adrenergic receptor. So what happens is, if this is a beta adrenergic receptor and epinephrine binds over here, so the effector domain, it changes its configuration. And yes, who will tell me what is going to be the next step? So there will be alpha subunit having what on it? GTP. Yes, so there will be GTP. Okay, so once this GTP comes up, so this is going to bind with a membrane bound protein. So so what was the name of this membrane bound protein? You remember what's the name of this membrane bound protein? Last example we discussed. Adenylyl cyclase. What happened to you? Okay, but anyways, here we are not talking about that. We are talking about phospholipase. This is a different cell, ठीक है ना? Let's say it's a muscle, normal general muscle. So phospholipase C. ठीक है, phospholipase C. So since this is a phospholipase C, now definitely the story will change a little bit. What do you mean by the word phospholipase? When you hear the word phospholipase, so what comes up in your mind?
Phospholipid breakdown.
Very good. So definitely its job is to break down phospholipids. So if where is phospholipid present in a cell? Where do you find phospholipid present in a cell?
Cell membrane.
Of course, cell membrane. So definitely its job is to cut the cell membrane, the phospholipids of the cell membrane. क्या बोलते हो?
हाँ sir.
Everyone agrees, na?
Yes sir, it's right.
Yes, it is cutting the cell membrane. Now, when it is cutting the cell membrane, so what happens is this membrane, like every phospholipid has got a name, right? So here also there is present a name. So what is the name? The name is phospho. So here there will be a large number of phosphoinositol diphosphate. There will be a large number of phosphoinositol diphosphate. And what happens is, when this phosphoinositol diphosphate is cut, it gives rise to two things. When phosphoinositol diphosphate is cut, it gives rise to diacyl glycerol and inositol triphosphate. So it is getting converted into diacyl glycerol and inositol triphosphate. ठीक है? So now what happens is कि inside our cells, inside our very beautiful beloved cells, you will notice कि there are present some special organelles with lot of extensive branchings. Can you recognize what is this organelle?
So Golgi.
This is not Golgi, but this is the ER.
Yeah.
This is endoplasmic reticulum. Now, why are we suddenly discussing about these things? The reason is कि this has large number of receptors for what? For IP3, inositol triphosphate. These are all IP3 receptors or inositol triphosphate receptors. So when inositol triphosphate receptors, they attach with this inositol triphosphate. Okay, when this inositol triphosphate is going to come up and bind over here, then what happens is this endoplasmic, do you know this endoplasmic reticulum contains a heavy storage of calcium? Do you know this? No.
Sir, mone chilo.
Acha. Though if you study physiology, muscle physiology, myology, then you will learn these stuff that there is muscle has got a lot of calcium. Muscles need a lot of calcium for contraction, and that muscle is mainly stored in the sarcoplasmic reticulum, which is basically a variety of ER. So what happens is when IP3 binds over here, then this ER will release large number of calcium, lay calcium, more calcium. So it is releasing calcium and calcium. Now what happens is there is present a very, very beautiful protein, and the name of that protein is calmodulin. It's a protein which will be modulated by calcium. So since there is a protein which will be modulated by calcium, you understand the meaning of the name calmodulin? So what happens is this calcium, once it binds with this calmodulin, it gets converted into a calcium calmodulin complex. Okay, it gets converted into a calcium calmodulin complex, and calcium calmodulin complex activates a very, very powerful thing. What is the name of that powerful thing? The name of that powerful thing is, it is called as CAM kinase. CAM माने calcium calmodulin. Calcium calmodulin is in short is CAM, and kinase का मतलब तो we have discussed already, so you know it. So it will convert it into CAM kinase, and CAM kinase will, again from the name only you can understand. If you remember Krebs?
হ্যাঁ স্যার, Krebs ওখান থেকেই হচ্ছিল আগেরটা।
Correct. Same CREB will activate. You know, CREB is again a transcription factor. So once again, this is going to activate the different transcription process. Understood?
স্যার আমি একটা আগে কথা জিজ্ঞাসা করা হয়নি
হ্যাঁ।
স্যার ক্রেবে তো ফসফেট বাইন্ডিং প্রোটিন কাজ করে, তাহলে এখানে তো ট্রান্সক্রিপশনে হেল্প করবে কি করে? এখানে তো স্যার রেপ্লিকেশনে হেল্প করার কথা না।
মানে বুঝলাম না ব্যাপারটা, এর সাথে রেপ্লিকেশনের কি সম্পর্ক হলো?
স্যার ট্রান্সক্রিপশন মানে তো ডিএনএ ব্রেক করা, মানে তো ফসফেটেজ না।
ট্রান্সক্রিপশন মানে ডিএনএ ব্রেক করা?
হ্যাঁ, মানে ডিএনএ থেকে আরএনএ ট্রান্সক্রাইব করা। ও হ্যাঁ, না ঠিক আছে স্যার, বুঝে গেছি।
হ্যাঁ,
বুঝে গেছি, আমি ট্রান্সক্রিপশন অন্য কিছু ভাবছিলাম।
ওকে,
হ্যাঁ
thank
ঠিক
you.
আছে।
Sometimes you give me great shock. Okay, I survived this one. Acha, now another thing. Look, so this is not the end of the story. Listen. See that dag, अच्छे हैं. Sorry, this diacylglycerol, that dag which came up. So इसको क्यों दाग आ गया? So let's understand that कि के दे गए छे. So this diacylglycerol which is present over here, even it has got a special role to play. It activates another protein, and that protein is called as protein kinase C. Last time it was protein kinase A. Now this time it is protein kinase C. Because phospholipase C, protein kinase C. So this time it is all protein kinase C. So when this protein kinase C will also get activated, then what will happen? This will again, like protein kinase C can again further activate directly or indirectly this CREB. Understood?
Yes.
Okay. So this is the basic idea. So you see, it's a different cell, so it's a different story. Here also there is GPCR, G protein coupled receptor. Everything is same, but still you realize that the action will be different. Now what will happen? If there is this transcription taking place, so according to what result will come out of transcription, accordingly that protein will start functioning. Understanding this? So any query from till this much?
That's it.
No. Okay, so this was about the G protein coupled receptor. Now let us take some example of enzyme linked receptor. So if we talk about enzyme linked receptor, so what is happening over here? So I am not decorating so much again. So let us suppose this is going to be the cell membrane, and let's say this is the receptor. Now each receptor, they have got a very dangerous type of amino acid, and that is called as tyrosine. I hope everybody knows that the single letter code for tyrosine is Y. So it contains tyrosine over here. Tyrosine residues are present. Now here what happens, here the story is this, कि if a ligand comes up and binds, ठीक है, suppose there is this ligand. So like I told you, let's suppose we talk about say growth factor. Okay, here GF is not girlfriend, it is growth factor. So some growth factor, say growth hormone, insulin also behaves in the same way. So if suppose the insulin comes up and binds over here, so depending on the affinity, suppose this has got the affinity, high affinity, and similarly this also has the high affinity, and both of them they attach here like this. Do you realize now they act like a single receptor? So actually they are a single receptor, but they are present in dimeric state. They are present in the form of dimers. So here what happens is that once they approximate to each other, now there will be autophosphorylation. Now I'm going to introduce this word called as auto. Here auto doesn't mean auto rickshaw, it is automatic. Self, sorry. Not really automatic, self autophosphorylation. So autophosphorylation mane last time you said addition of phosphate. So there will be addition of phosphate on whom? On the tyrosine residues. Your tyrosine residues, that is why it is called as a tyrosine kinase, because it's such a tyrosine which is having phosphorylation action. But here it is phosphorylating whom? Itself, autophosphorylating. So anyways, so suppose, what to say, so suppose here you have the tyrosine, and this tyrosine gets attached to, let us suppose, phosphate. Just deepening the color so that you can distinguish thoroughly. So it is attached to phosphate now. Now once it is attached to phosphate, what happens is that there will be another protein coming up that is called as the SH2. Okay, so now what kind of a protein? Here there are some new proteins that we'll be talking about. So you have to know about these proteins, like what are these proteins, what do they do, and all these things. So anyways, so over here if we talk about this kind of a protein, so it is called as a SH2 protein. Okay, so there is a SH2 domain present or formed over here. So I'll write over here SH2. Okay, have you heard of this name of this protein before? No?
No, sir.
Acha. So don't worry. So there is this SH2 subunit, and of course SH2 subunit is going to further bind with SH3 subunit. SH3 subunit.
Sulfate based, sir?
No. So so this is like SH2 will further bind with SH3, and then they are going to give us some biological effect. Okay, so this is the basic story in short. What is happening here? The different molecules will have their different again action. Different molecules, okay. The action is not always same. Like suppose if I say like story different, like story changes according to the ligand. Let's suppose this was the growth factor. So if really this is the growth factor, then actually what should have happened? So there is this protein called as a G protein receptor. G protein ka receptor binding protein. So like suppose I am showing here. So what would have happened? There was a protein called as GRB, G protein receptor binding protein 2, GRB2. And I am giving you a real example, like what will happen, not hypothetical. So if this is GRB2, so there is another protein that gets activated, that is called as a son of 7-less protein or SOS protein. SOS ka full form is son of 7-less protein. Okay. Now when son of 7-less protein gets activated, it further activates another protein which is also a sort of that trimeric protein, G protein. It is also again a G protein, and that name of that protein is RAS protein. RAS.
Sir, SOS a real name, son of
7-less. Son of 7-less.
Yes, sir.
Okay, so there is going to be RAS protein, and RAS protein further activates another protein that is called as the RAF. So that leads to formation of a RAS-RAF complex. Okay, and if there is RAS-RAF complex formation taking place, then what will it do? It is going to activate MAPK. What do you mean by the word MAPK? Mitogen activated protein kinase. Do you understand the meaning of that word, the importance? Mitogen. So there will be some sort of mitosis. Only then growth will take place, na? So if you are giving, say, growth hormone, then growth will take place. Okay, so there will be, say, mitogen activated protein kinase, MAPK. But suppose, for example, if this is the growth hormone you are giving, but like I started the story, that suppose this is insulin. Suppose this is insulin, then what will happen? Then this kind of story will not happen. So here what will happen is that there is going to be that PIP2 getting broken down into inositol triphosphate, blah blah blah, and that will lead to what? That will lead to increased phosphofructokinase. That will lead to increased GLUT4. So phosphofructokinase is increasing. Mane glycolysis will increase, decrease, or remain same? What do you think?
Sir, phosphofructokinase increase korche.
Increase korche. That means sugar will be like gradient of the sugar is towards inside of the cell or outside of the cell?
Gradient inside of it.
Inside of the cell, of course. So you see, more there will be increased PFK, or more there will be increased GLUT4, more sugar will be absorbed by the cell. And do you realize that is the job of insulin? Insulin is going to clean up your blood, take up all the sugar in this mechanism. Understood? So if you start understanding these ways, then like it will be very easy. Like this was about the growth factor, this was about the insulin. What about growth hormone? Because I told you that even growth hormone actually has got a cell surface receptor. So what about growth hormone? So for growth hormone, there is again that kind of a dimeric receptor. Like suppose, I'll just tell you in short, just to give you the idea. So let's say this is again the receptor. Sorry, this is again the membrane, and let's say there is this receptor and there is this receptor, and this is associated with what? This is associated with, what are these? Tell me rapidly.
Tyrosine.
Correct.
Tyrosine.
Yes. And suppose there is, what will happen to the next step? So in the next step you will notice that there is growth hormone coming up, isn't it? So this is the growth hormone, and when growth hormone will come up, so what will happen? This, correct. So this is going to form one single unit, and when this is going to form one single unit, then you will also notice that they are getting phosphorylated, the phosphate, the tyrosine. So they are all getting phosphorylated. Now look, what happens is, over here, if this is not only getting phosphorylated, there is another protein that is getting phosphorylated. So that is called as a Janus kinase. The word is Janus kinase. Okay.
Yes, sir.
So what happens is that there is this protein called as JAK, Janus kinase. So JAK also gets phosphorylated. So two people getting phosphorylated right now. One is tyrosine is getting phosphorylated. I am showing one so that there is no hodgepodge. But so this is getting phosphorylated. Let's see who all is getting phosphorylated. And JAK2, actually it's called as JAK2. So Janus kinase 2, JAK2 is also getting phosphorylated. So if JAK2 getting phosphorylated, that is one thing. If tyrosine is getting phosphorylated, that will further phosphorylate another thing that is called as a STAT. There is a thing called as STAT protein. So what is STAT? See, from the name only you will understand. Signal transducer and activator of transcription. So you understand what it will do? Signal transducer and activator of transcription. That means if you phosphorylate this thing, there will be what? What will be going on then? There will be transcription, altered transcription. So you see there will be in some sort of transcription going on, and there will be some growth and things will happen that way. Getting the point?
Yes.
All right. So these are the various, like this is the idea. Like suppose I'll just give you a few more ideas so that you can play around with these concepts. Like suppose there is present, have you heard of tumor growth factor?
Yes, tumor growth factor.
TGF.
Uncontrolled একটা growth factor হয়। ওইটা বোধহয়।
See, there is a thing called as, well, like not tumor growth factor, I'm sorry. It's transforming growth factor. Transforming growth factor. It's a cytokine. Okay, so there is a cytokine called as transforming growth factor. Have you heard of anti-Mullerian hormone? Anti-Mullerian hormone or anti-Mullerian factor?
Yes, শুনেছি।
It is present in it is secreted by the Sertoli cells in your testis. Have you heard of the hormone inhibin?
Yes, sir.
So how do they work? So suppose I talk about a transforming growth factor. So once again I'm going to make this the membrane, and you will see key again I'm going to, okay, I'm making a few membranes over here. So again you will see that there is going to be receptor, monomer or dimer. Looking at it, what do you feel?
এটা মানে রিসেপ্টরটা ওইরকম ডাইরেকশন টাইপের রিসেপ্টর
মানে ডাইমার, monomer তার মানে ডাইমার।
হ্যাঁ
And here it is different, like this one is called as, let's say this is type 1 receptor and this is type 2. Mane here it is not like they are same, one is type 1, other one is type 2. Now suppose I talk about this transforming growth factor. So transforming growth factor is suppose like this, TGF, and let's specify TGF beta, transforming growth factor beta. So if transforming growth factor beta comes up, so you realize ki this is type 1 and this is going to be type 2, and they will bind over here. And if it binds over here, now this area which is present, this portion, okay, so now what will happen? Type 1 initially, look, type 2 only was having phosphate, but type 1 was not having anything. Now type 1 will also have phosphate, understood, because the receptor got attached. So even type 1 will have a phosphate, and when type 1 gets a phosphate, they activate another protein, and that is called a SMAD protein, SMAD. Okay, so there is going to be SMAD protein binding over here. So I'll write over here like this. Okay, so this is, see, SMAD is attaching to which one do you think, type 1 or type 2?
Type 1.
Yes, so remember this, type 2 receptor is constitutively phosphorylated and active, but type 1 was not. Initially type 2 was active, already active, constitutively, it is called as constitutively active. As per their constitution it is active, but type 2 it was not active. I'm sorry, type 1 was not active. So when the ligand will bind, then only type 1 will get active, understood? So what happens is, now SMAD protein will bind, the name is SMAD, SMAD. So when SMAD protein will bind, this will again cause transcription. So henceforth, today onwards, you also know how cytokines work. You understand how important this discussion is?
Yes, sir.
So do you know, like, there is a process called as erection of penis, penile erection. So penis is made up of what kind of tissue? Connective, epithelium, like what is it made up of? Iron, stone, brick, cement? What is penis made up of?
So epithelium connected মানে
What is the main bulk? Would be doctors should know. All the would be doctors, you should be knowing that what is penis made up of. Anyone knows? Is it made up of steel?
epithelium.
Epithelium. So basically penis is just a epithelial membrane. Okay, rest of the people, what do you think? What is penis made up of? Nobody knows what is penis made up of? All would be doctors and no idea about what is penis made up of? What do you think? Copper wire?
Sir, muscles.
Tell.
Muscles.
Thank God somebody knows it. Yes, penis is made up of muscles.
স্যার আমি বলেছিলাম আপনি কানেক্টিভ টিস্যু আপনি
Koi. See, tissue, if you talk about tissue as per as histology is concerned, there are 4 types of tissue: epithelium, connective, muscle, and nerve. So, connective muscle is not a connective tissue proper. Muscle is a specialized connective tissue, you can say, but actually speaking, it is separately considered. Connective tissue will be different. So yes, it is muscular tissue. Now this is a weird kind of a muscular tissue. This is such a type of a muscular tissue which can undergo erection. So do you know how does erection take place? Anyone who can tell how the penis gets erect? Any idea?
So airfield মানে ওরকম নিয়ে the blood supply through the airfield হয়
Air filled. So suppose I take a needle and I puncture the penis, so there will be and erection gone. Okay, anybody else has any other idea?
blood flow হচ্ছে বলে ওটাকে মানে
Blood flow, yes, finally. So that means inside this muscle there are present large number of empty spaces which are called as sinusoids, and those sinusoids which are present, they get filled with blood. Now when do you think they get filled with blood? So when there is nitric oxide coming up, when there is acetylcholine coming up, when there is vasoactive intestinal peptide coming up, at that time you will see that there is going to be vasodilation. Okay, but this is a single one line, but actually it is not so simple. Do you know why it is not so simple? I'll just show you what happens here. So you see, this is going to be your, imagine this is your bloodstream. So if this is your bloodstream, do you realize this is your endothelium lining? क्या बोलते हो? This can be your endothelial lining.
that's it.
Now if this is your endothelial lining, can you imagine in this way that this is going to be the penis muscle, blood vessel supplying the muscle. So this is going to be your penis muscle. Let's say this is the penis muscle. So first thing is, like I said, what is the receptor present over here? So it's going to be a weird kind of receptor. I'll show it here. Okay, so there is this receptor, and let's suppose acetylcholine comes up here. Acetylcholine. ठीक है ना? This is going to be acetylcholine. So as soon as acetylcholine comes up over here, so what happens, you know, there is increased calcium inside endothelium. So this much you can understand easily. Am I disconnected?
Yes, sir.
Oh, so you are there, one of you. Okay, so
কানেকশনটা একটু আটকে আসছে।
acha, okay, so anyways, let's see if there is any further disturbance or not. So as I was saying, that suppose acetylcholine comes up over here, so intracellular calcium increases, and even it can be activated by large amount of another molecule. I hope you have heard the name bradykinin. So even bradykinin can also do the same thing, increase the calcium level. Now when the calcium level is increased, so what happened is that there is going to be endothelial nitric oxide synthase getting activated. So calcium activates, I'll just show you, calcium activates, this is the endothelium, right? So calcium will activate endothelial nitrous oxide, sorry, nitric oxide. Okay, so nitric oxide synthetase, NO synthetase, understood? Don't say nitrous oxide. Nitrous oxide is N2O. Nitrous oxide is laughing gas. During penis erection nobody laughs, okay? So don't do that blunder. That is, nitrous oxide is laughing gas, N2O. This one is nitric oxide, NO. ठीक है ना? So NOS, nitric oxide synthetase, and E for endothelium. This is the endothelium. So the endothelial nitric oxide synthase. So when endothelial nitric oxide synthase will get activated, so what happens is, here there is a very very beautiful amino acid. The name of the amino acid is arginine. Quinine, arginine. Arginine, in presence of oxygen, and this nitric oxide synthetase, in presence of oxygen and nitric oxide synthetase, will produce nitric oxide, and of course this arginine will get converted into citrulline. Okay, now nitric oxide formation we have got. Now what? Now this nitric oxide, this is going to move into the penis muscle. So this nitric oxide will travel, and this is going to enter this penis. So once it enters this penis muscle, now what happens is, so there is present something called as GTP, and this GTP is activated when nitric oxide enters. So when nitric oxide enters, sorry, it activates a protein that is called as guanylyl cyclase. It activates a protein guanylyl cyclase, and when guanylyl cyclase gets activated, then GTP gets converted into cyclic GMP. Then GTP will get converted into cyclic GMP. Now when cyclic GMP will get activated, now what do you think? It will be protein kinase A or protein kinase C which will get activated? What do you think?
সে সাইক্লিক করে তো সি অ্যাক্টিভেট হচ্ছে।
না, that was phospholipase C, and if it was A,
ও হ্যাঁ, ওটা ফসফোলাইপেস, রাইট।
so this should be
protein kinase A.
protein kinase A was when there was cyclic AMP, so this is going to be protein kinase G.
What?
Okay, so you see, it's very simple. It's very simple to remember. So it is protein kinase G. So protein kinase G will cause vasorelaxation. So vessels will relax. So this will cause vasorelaxation. Okay. Inside the penis, even lot of drugs work. in the penile muscles. Like suppose there is this, even penis muscles has got a lot of receptors over here. Suppose here we talk about another receptor of the penis. This is specifically in the penis muscle. So that is the lot of we can say cytokines. So different types of cytokines can also bind over here. So let's say there are a lot of cytokines which can attach here. Even there can be lots of steroids which can directly enter in, because steroids though we have discussed now, I'll tell you later on, but for the timing though you understand that they will directly diffuse in, they don't need a cell surface receptor. So this one, when it enters in, so over here this is not going to be a endothelial nitric oxide synthetase, but it is going to be another type of nitric oxide synthetase. So we will call it as a INOS. This is not the endothelial type, so we will call it as INOS. So whatever the situation will be, so actually steroids inhibit it, mind it. So I think I should use some different color here. So steroid has the capability to inhibit this entire procedure. Steroids inhibit it. So what is it inhibiting? It is inhibiting formation of a different kind of nitric oxide synthesis, that is known as INOS. Last time it was ENOS, that is endothelial NOS. This one is not the endothelial NOS, so it is INOS. And that will start again as usual, that will increase the nitric oxide level. Once again the same thing, that if the nitric oxide level increases, the story will be, do you realize? Same story. Nitric oxide synthesis से मतलब था ना, so once it came up like that.
So our cycle down.
So you see, this is the way even the penis muscles work. Okay, so in case of different molecules, now I have given you the idea ki how the things are going to work. Okay, so
Yes, sir.
so everybody's understood this thing ki how it works.
Yes, sir.
Great. So just one last thing. This was all the story of your cell surface receptor. We haven't discussed anything about the intracytoplasmic receptor. So I think at least one discussion we should do on it, because that's very simple. So I think one discussion we should do on intracytoplasmic receptor, and we will finish today's lecture. So over here, now it is going to be a little bit different. So this is going to be the intracytoplasmic receptor.
স্যার বলছি আজকে যেটা একটু লিখিয়েছেন মানে কি করেছেন, তাহলে একবার একটুখানি মানে গ্রুপে পাঠিয়ে দেবেন, তাহলে একবার দেখে নিলে আর একবার সুবিধা হবে। মানে এই জায়গাটা একটু ভুলে যাচ্ছে তো, না মানে ফসফোরাইলেস, ওই সাইক্লিক এমপি অ্যাসিটাইন ওইগুলোকে একটু দেখে নিতে পারবো।
হ্যাঁ, বুঝলাম না কি করতে হবে
স্যার বলছি এই যেটা আপনি স্কিম্যাটিক ডায়াগ্রাম করে করেছেন, এটা একবার একটু যদি গ্রুপে পাঠিয়ে দেন ভালো হয়, তাহলে একটু দেখে নিতে পারবো।
আমি লিংক এমনি শেয়ার করে দেবো। সুধৃতি অলরেডি ইজ অ্যাবসেন্ট না, তো আই উইল শেয়ার দ্য লিংক।
হ্যাঁ স্যার,
হ্যাঁ, নো প্রবলেম। আই এম রেকর্ডিং দ্য লেকচার।
ওকে স্যার।
হ্যাঁ, তো let's talk about the intracytoplasmic receptor. So once again, this is going to be a new cell, new membrane, new kahani, new participants. And right now here I'm going to talk about one receptor. Now this is going to be our dangerous kind of a beautiful receptor, and this receptor, yes, this is the receptor. Okay, now in this receptor, okay, acha, I'll make a different kind of receptor. Let me make a different receptor. Let's suppose this receptor has also got a ligand binding domain. This is the ligand binding domain, and this portion, it winds around a zinc molecule. It is called as a zinc finger, because it will have some cysteine residue. You know cysteine, not 16. Cysteine mane it's amino acid. So cysteine residue, cysteine, you know cysteine, methionine, sulfur containing amino acids. So cysteine residues are present over here, and they loop around a zinc, so that's called as a zinc finger, and then comes up this effector domain, and this effector domain comes up. But the problem is that in normal circumstances this entire receptor is blocked. So who blocks this receptor entire? So it is blocked by a very very special protein, and that protein is called as a heat shock protein. Now what happens is when let's say this thing, a hormone enters, let's say there is this hormone. So whenever this hormone will enter, so first thing that should happen, that is this heat shock protein will go away. ठीक है ना? So this heat shock protein, it really goes away. Now, do you realize that it is more like a competitive inhibition? Here what is happening? The hormone is displacing the heat shock protein. Hormone is displacing, removing the heat shock protein and sitting in its location, sitting in its place. So basically this area is now empty, correct? And once this area goes empty, so our beautiful hormone can easily bind.
Yes, sir.
Now so now we will notice that if this is the cell, this is the cell, so here this is the nucleus. So this is going to be the, suppose, the nucleus. This is the nucleopore. You know, nucleus contains some tiny nucleopore present over there.
Yes, sir.
So this receptor, this hormone, like the receptor attached with the hormone, this entire complex, this will be able to pass through these through these pores, and slowly and gradually it will be able to pass through these pores, and this is going to alter again transcription. Like this, somewhat like this. See whether you understand or not. So this will give rise to what? So this can give rise to some different kind of mRNA, and this mRNA can easily leak out into the cytoplasm. Now this mRNA, if it really leaks out into the cytoplasm, then what will happen? This will be read by some ribosomes, E site, P site, A site. You remember that? Now if this ribosomes, so if these ribosomes, they read it, so slowly and gradually they will produce some, some protein, and we will get some desired action. So this will be true for say aldosterone, testosterone, estrogen. This is true for everybody. Got it?
Yes.
Everyone, rest of the people, ठीक है? And yes, where is our other doctor, Devasmita? Understood? I think she's gone. Anyway.
না না স্যার আছি, মানে আমার ফোনটা একটু ডিস্টার্ব করছে,
আচ্ছা, ওকে,
ওই জন্য কেটে কেটে দিচ্ছি।
আচ্ছা, ঠিক আছে, তো ফাইন, ঠিক আছে। সো আচ্ছা, I think today we should stop over here, okay? And next class we will be continuing with the rest portion. We will finish pharmacodynamics, okay, next class, because there is nothing much left. This was the main heart of the topic, so we have done that. So next class we will be finishing with the dynamics, and hopefully I'll try to do